Describing matter. The characteristics or properties that are used to describe matter can be classified in several ways. Any characteristic of a material that you can observe without changing the identity of the substances that make up that material is called a physical property. A physical property are things like color, shape, size, density, melting point, and boiling point. For example, if you have a red piece of paper and tear it in half, you still have red paper. You did not change the physical property of the color by tearing the paper. When given an object, for example, a stuffed teddy bear, and if you were asked to describe it, you would begin probably by describing its texture, its color, or its shape, all of which are physical properties. You could then go into measuring the diameter of the bear or the mass of the bear, which are also physical properties. Some physical properties describe the behavior of a material or a substance. For example, the substance iron has a physical property of being magnetic because it's attracted by magnets. Chemical properties differ from physical properties in that they are characteristic of a substance that indicates whether it can undergo a certain chemical change. The tendency, for example, of a substance to burn, or its flammability, is a chemical property because burning produces new substances during a chemical change. Paper has a physical property of a rectangular shape and white in color. However, its chemical property is flammable. When you tear a piece of paper, you change some of its physical properties, like its size and its shape. However, you have not changed the identity of the material that make up the paper. It is still paper. This is an example of a physical change, which is when a substance can change in size, shape, or state of a matter, and the identity does not change. The best example of a physical change is water, which freezes, boils, evaporates, or condenses. Even though it changes its state of matter, it still keeps the property of water, whether it's in liquid, drinkable form, or an ice cube, or even steam boiling from a pot. When a change occurs to a substance that completely changes that substance, a chemical change has occurred. For example, when you take cookie dough and place it in the oven and bake it for 10 minutes, that mixture of cookie dough changed to a cookie. Using heat for a chemical reaction, it cannot turn back to cookie dough. It has completely changed into a new substance. Another example would be if you left your bike out in the rain and came out to find rust on it. That formation of rust indicates a chemical change has taken place and it can't turn back to the metal it once was. Now you say, well, I could sand off that rust, but what you are doing is you are just sanding off the metal that turned to rust, and now once you sand it, you're just exposing the metal that was beneath that rust. If you continue to do this, there will eventually be a hole because you are just taking off layers of that metal. Another example, fireworks, which have a chemical property of being combustible, will go through a chemical change once lit and they explode into the sky. Now, from this previous slide when we just discussed that firework exploding, if you were able to collect all of the ashes, all of the pieces of the torn up container, all the oxygen in the air that combined with the flames, and all the smoke and gases that escaped, and you measured all the masses together, you would find that that mass of all those parts would equal the original firework. This is because during a chemical change, matter is neither created nor destroyed. According to the law of conservation of mass, the mass of all substances that are present before a chemical change equals the mass of all the substances that remain after the change. Time to show what you know.